Sir, unmute yourself.
Good morning, everyone. Today is lecture number 21 of this advanced concept in steel technology. And today's topic is again on this steel making process, that is basically advanced continuous casting and its advantages over conventional continuous casting. So, basically, as we know, uh, we are not basically doing nowadays in cut casting, which is a batch process because we have to pour a mold. We have to pour the liquid steel into a mold and we'll get a product, right? But we are not doing that. Actually, nowadays we are producing castings or those cast product continuously. Hmm. Continuously, we are pouring the liquid steel into the mold, and continuously we are withdrawing the solidified cast product, right? The continuous process. And also, we have discussed about many advantages we have in continuous casting, like the loss of metal will be less. We can get 100% yield, and we can have less segregations. We cannot avoid segregation completely, but we can have less micro and macro segregations. We can have we can prevent the reoxidation, resulfurization, and we also can get many good mechanical properties in the cast product. But the thing is, what this continuous casting is fine, but our priority is to produce continuous cast product at a cheaper rate, or we can say we should have a higher rate of production, or we can say that we should have a cast product which will have a very good mechanical properties in terms of its strength, like that. So that means for an industry, for a steel industry, the priority is always two things, two to three things are there, which are three important things. First important thing is the rate of production should be higher, right? At a minimum time, we should produce more amount of products so that we can sell it quickly and we can earn profit, right? So that is the rate of production should be high. And second important part is uh, the quality. The quality of product which it forms should be basically superior quality. It should have in terms of its property, in terms of its, you can, as I told, we have discussed about many metallurgical attributes, like it should contain less inclusions, the microstructure is good, should be good, like it should have finer microstructure to provide good strength, right? And defects should be less. It should not contain any kind of defect like cracks, interior cracks or outside cracks. It should have good surface finish, right? And many things are there, right? And there should not be any casting defects like porosity and all. So these are the things. One is the high rate of production and quality should be good. And another important point is the cost of production should be also minimum. Economical production should be there, right? Three things: rate of production should be high, the production cost should be minimum, and the quality of product should be good. So these are the three criteria any industry follows basically to attract the customer, to get profit. So that is the reason why this continuous casting, some advancement has happened in the recent years. Some advancement has taken place to do these things, to increase the quality or to increase the rate of production otherwise, or in terms of this economic ground, so that we can produce the steel at a lower cost. So let me tell you one and the important point. Like steel, if you look into the automotive sector, automotive sector means the sector which are used for manufacturing these automobiles like car, bus, trucks, and all vehicles. So basically, they are using steel for their outer bodies or for their inner bodies also, right? So most of them are using steel and aluminium, right? Nowadays, aluminium is replacing the steel, but still we are using steels in majority. So a car manufacturing industry, they need basically sheet, or strips. You can call strip or sheet actually, steel sheet. So this steel sheet have a dimension of like, if I'm talking about the thickness, which is very important, the dimension is basically start from 0.77 mm to like 3 to 3.5 mm or 3.3 mm. So this is the range basically. So if you look into your car, if you have a car, if you look in the car and you carefully look into the car and you can see the outer body, if it is made up of steel, the thickness is like 1.3 mm or 2 mm, like that. It varies from companies to companies. This is the range 0.77 mm to 3.3 mm, like that. This is range of the sheet, or you can say strip. So now if you look, the development is near net shape casting. I think I have talked something about this earlier. Near net shape casting. So near net shape casting is the development actually, which has happened to the continuous casting process. So the near means closer, close. And net shape means I'm talking about the final shape. Final shape means final shape of the strip or the final shape of the sheet, steel sheet, which will be used in the car bodies, for example. Right? So near net shape casting means in this kind of continuous casting process, we can generate a final cast product whose shape or whose dimension is close or near to the end product or end use. That means after doing continuous casting by near net shape casting, you can get a cast product which directly can be used in the application area. Or in other words, if it cannot be directly used, the minimum processing will be there. Maximum processing will be cut off. That means the product is so thin, or the dimension of or the thickness of the product is so thin that we do not have to process it more. We have to avoid the much processing on it. Processing here means basically I am talking about the rolling part. The extent of rolling should not be high, right? So this is the advantage. Okay, anyways, so this is the biggest breakthrough in the area of continuous casting. Near net shape casting is the biggest breakthrough in the area of continuous casting. So we have to see this in the production of flat rolled sheet. As I told, this flat rolled sheets are used for manufacturing of car bodies or automotive bodies. We have continuous casting processes. These are the continuous casting processes we have. One is the conventional slab casting, because if you remember in the earlier lectures, slabs are generated so that we can produce a coil or a sheet out of that. So one part is the conventional slab casting, and the part is the near net shape casting. So you understand, conventional slab casting is nowadays not used. Few industry they have, but nowadays many industries are opting this technology, near net shape casting. So what are the other classes of near net shape casting? Or what are the different types or category? One is the thin slab casting, one is the strip casting, one is the beam blank casting. So this is not in your syllabus. We'll not discuss about this one. We'll discuss about the thin slab casting and strip casting. So thin slab casting and strip casting are different categories of this near net shape casting, right? Now we'll discuss the difference. What is the difference between this conventional slab casting and this thin slab casting, strip casting? So you can see the difference between all this casting is the thickness of the cast product. What is the thickness of the cast product? We'll get whether it is very less or it is medium or it is very high. That differentiate the conventional slab casting with the thin slab casting and strip casting. And another difference is subsequent operation given to get the product, final product. Get the final product. Here, subsequent operation means I'm talking about the rolling part, basically. Here, more rolling operation will be given, or less rolling operation will be given, or a single rolling operation will be given, so that we will get a final product. That will also differentiate the conventional casting, slab casting, with this strip casting and beams. This thin slab casting or strip casting. Here the continuous casting type. So continuous casting type was in this table we have in this end continuous casting types, and here the thickness of the cast product. So you can see in the conventional continuous casting, basically conventional continuous slab casting, you can see the slab which is produced have a thickness of around 150 to 300 mm. So this is a very high thickness of the slab which is generated from the conventional continuous casting, right? But if you look into the thin slab casting part, which is a near net shape casting process, you can see the thickness of the slab generated is 50 to 80 mm. So you can see that means in the near net shape casting we have reduced the thickness of the slab which is generated. It is very high, but it is very less. And if you look into the strip casting, or sometimes it is called direct strip casting, the dimension of the strip which is obtained is only 1 to 5 mm. So you can see the difference here in the thickness of the cast product. Thickness is maximum here in the conventional route, but in the new route, that is thin slab casting, it is decreased to this much. But if we are generating a strip directly from the molten metal, from molten steel, we are getting a thickness of 1 to 5 mm. You can compare this thickness with the steel sheet which is used for manufacturing of the car. That is, you understand now, it is close to that 1 to 5 mm, because as I told, the thickness of the sheet which are used in the manufacturing of the car is 0.77 mm to 3.3 mm or 3.5 mm maximum. So you understand why these two processes are called near net shape casting, right? This is justification for that. And you can see here the thin slab casting, the thin slab is produced to avoid maximum intermediate process to get thin sheet, right? Because you understand, by doing thin slab casting we are getting a dimension thickness of this much of the cast product. So you understand what will happen, maximum intermediate process will be avoided. And here you can see in strip casting, here direct casting of strip from liquid steel is happening, right? That means from the liquid steel we can directly produce a strip, which is very interesting obviously, because you understand in this part, if we are generating a cast product, a slab, by using conventional continuous casting process, then we have to do rolling, again we have to do rolling, again we have to do rolling. So many rolling process, intermediate rolling process will be done, and many intermediate heating process will be done before rolling to get this strip. But here in the strip casting, we are directly get a strip out of the liquid metal. And all the things I have explained is written over here. Car wheel drive use steel sheets of dimension in the range of 0.77 mm to 3 mm or 3.3 mm, like that. Basically, which varies from company to company. So here, direct strip casting is an advantageous one because of getting a thickness of strip in the range of 1 to 5 mm, which is close to this required car manufacturing sheets. That's why it is called near net shape casting. Now, what is the advantage of the near net shape casting, or what is the advantage of this thin slab casting or direct strip casting? So these are the advantages, and these advantages are on the basis of, as I told, economy, cheaper rate of production. So one is the energy saving, right? We can save a lot of energy, right? Energy in terms of electricity to generate heat. And second one is we can save capital cost. The capital cost means installation of various rolling machines will be avoided, right? So that we can save a lot of capital, lot of money can be saved here. And second, operating cost. Obviously, if we have lot of rolling machines, the operating cost will be increased obviously, because and simultaneously we can have lot of heating furnaces also. So here heating furnaces will be avoided, and lot of rolling machine will be avoided, so that we can save this one. Capital cost and operating cost can be saved. Obviously this will lead to the economical production, right? Now this is a very good diagram taken from a textbook, um, from this iron and steel making, Ahindra Ghosh and Amit Chatterjee. Iron and steel making. So you can see this is a very nice figure or image which is showing different type of continuous casting, as well as conventional casting, as well as your most conventional casting, that is ingot casting. So this part is showing ingot casting, which is the earlier route to get a cast product, and this part is showing you the conventional continuous casting, that is conventional slab casting, and this part is showing you thin slab casting, and this part is showing you the direct strip casting. And I will explain the process here. You can see this is the ladle, you understand, ladle which carries liquid steel, huh? And here you can see ingot casting. So the liquid steel is poured into the molds, and from the mold we'll get a ingot. So this is not a continuous process, this is a batch process. So we'll pour all the molds, and after solidification we'll get a different ingots, and that it is goes to the reheating furnace. So it is heated again. After heating, it is then goes to the slab mill to get slabs. Then after getting a slab from the slab mill, it is again go into the reheating furnace. Again after it is heated, the slab is heated in the reheating furnace, it will go into the roughing mills. Again there is a reduction in the thickness will be there in the roughing mills. After passing through the roughing mills, it will go into the hot strip mill. Huh. HSM is nothing but the hot strip mill to generate a strip. Then it is undergoing pickling and heat treatment. So pickling is done to remove the scale, the oxide scale which has formed. Huh. Then after removing the oxide scale, it is given heat treatment, required heat treatment, and finally it will goes to cold rolling mill to give cold rolling to the materials to get a desired uh, strength or desired properties and desired reduction in the cross sectional area or thickness, and finally it will send to the customer for selling. So this is the fun. So you can see, if we are using the most conventional route, that is ingot casting route, we have to use lot of intermediate processes to finally get a strip and finally get a rolled product which will be sold to the customer. But then next process comes, that is continuous casting. You can see this part. So from continuous casting you can see we are directly generating a slab. So here, this one, we are getting a slab, and slab is reheated in the reheating furnace. Then after it is getting reheated, it will go to the roughing mills for the reduction in the thickness. Then after that, it will go to the hot strip mill to further reduction in the thickness to get a strip. It will undergo pickling and heat treatment, and finally it will go to the cold rolling mill and it will sell to the customer. So you can see these are the furnaces and the rolling mills we are using. So that means by using continuous casting to generate slabs, we are avoiding these two things. Reheating furnace here and slabbing mill is avoided. But now these two thin slab caster. So in this thin slab caster, we are generating thin slabs. So you can see we are coming to here now. That means you can understand from the figure, we are avoiding roughing mill, we are avoiding reheating furnace, we are avoiding slabbing mill, we are avoiding reheating furnace here. These four things will be avoided now. There is no requirement of these four things: reheating furnace and this roughing mills and slabbing mills. We can directly produce a thin slab, and we can directly goes to the hot strip mill. Finishing strand of hot strip mill. Then after getting a required dimension, required thickness, it will directly go to the pickling and heat treatment process. Then it will go to the cold rolling mills. So finally, it will go to the customer. Then finally, the again near net shape casting, that is strip caster. You can see we are directly pouring the liquid steel into the roller. Twin rollers are there. This is one roller. This is another roller. So this is one roller and this is another roller we have. So we are directly pouring the liquid steel into the roller, in between the rollers, to get a strip. So that means we are not using any kind of mold. You can see this is the advantage of this. But here in this case, we are using a mold. The mold is here. We are using a mold here. We are using direct mold here. But here we are not using any kind of mold. We are directly pouring the liquid steel into the twin rolls. Two pair of water cooled rolls will be there. So it will roll the solidified liquid steel into strips directly. So you can see we can avoid all these things. We can directly produce a strip, and we can either sell it to the customer, or we can do cold rolling on the strip to get desired thickness, and we can sell it to the customer. So you can see what is the advantage of thin slab casting and strip casting from this image only. One advantage we are getting is we can avoid lot of intermediate processes, such as many rolling processes, many reheating processes. So due to this, what will happen? We can avoid installation cost, or capital cost will be avoided. We can also avoid our operating cost, right? We can save lot of energy also. All the things which I have explained is written over here. We can see thin slab casting. You can see it bypasses roughing mills completely. You can see the roughing mill is here, but after getting a thin slab, we are directly going to the hot strip mill. We do not have to go into the roughing mills. Then thickness of the cast product is 50 to 80 mm. Already we have seen that, which directly enters the continuous reheating furnace, and after this reheating, it enters the finishing strand of the hot strip mill. Due to this, it saves energy and cost. So we can save the cost and energy. The cross-sectional area of the mold of the thin slab caster is small. This is another interesting point about thin slab casting or caster is the mold have a less cross-sectional area than the conventional slab caster, but it gives rise to some problem. What is the problem? This create an issue due to high turbulence in the mold. So you understand, in the conventional slab caster, the mold size or mold cross-sectional area is big, but in the thin slab caster, the cross-sectional area is less. So due to which what happens? High turbulence will be there in the mold by the timming stream. What will happen if there will be high turbulence? Then it will lead to mold flux entrapment, which is not good on the surface and give rise to surface defect. So there is a solution to this. The solution is what? We can either use funnel shaped mold instead of flat mold. We can use funnel shaped mold with large cross section near the meniscus. So in the meniscus we have large cross section, but at the bottom part we have a tapered cross section because it is a funnel shaped mold. So due to which the turbulence will be reduced. And second one is for parallel shaped mold. If we are using parallel shaped mold, we can use electromagnetic brakes. These electromagnetic brakes will do what? They are effective in damping the turbulence. So turbulence can be damped. The turbulence can be reduced by using these electromagnetic brakes if we are using parallel shaped mold. There is certain limitation to this process, the thin slab casting process. There is some limitations. What is the limitations? Total production is low, but total production is low than that of in any conventional casting. So production is less. but it has other advantages as we have discussed. Then other advantage of this casting, that is thin slab casting, is we can produce high quality strips with less segregations. So segregations will be avoided. We can generate fine grain size, and we have high strength. So these are the advantages in terms of metallurgical advantage. Now strip casting or direct strip casting. Already we have seen the diagram. So here what happens? Setup used in the strip casting is totally different from the thin slab casting. What is the difference in the setup? You can see this is the setup for the thin slab casting. This is the setup for the strip casting. You can see here mold is present, but here there is no mold. It is written over here, such as there is no mold at all, right? So in the direct strip casting, there is no use of mold. We are directly, a popular method is used of twin roll caster. So use two water cooled rotating rolls, right? So we are not using any kind of mold here in the strip caster. We are using directly twin rollers, which is water cooled. Here directly the liquid metal is poured into the gap of this roll, and rolled strip comes out. This strips comes out, either goes into the cold rolling process or can be directly sent to market, which already I have explained here. It can goes to the cold rolling mills, or it can directly send to the customer. Some advantage we'll see here. Rapid solidification occurs here, which gives a lot of advantages. What are the advantages we'll get from this strip casting, direct strip casting, compared to the conventional casting? Thin strip have very small equiax strain. So first advantage we are getting is we'll get an equiax strain. First advantage we are getting is the rapid solidification. So rapid solidification leads to small equiax strain. Segregation will be minimum, and fine inclusions will be there. So rapid solidification leads to finer grain size. That's why it is small equiax grain, and grain is also equiaxed. And another one is the segregation will be minimum, because solidification is so fast that there will be no segregation. There will be no separation of the alloying elements, or any impurities will be there. And inclusions are of finer size. As I told, if inclusions will be there in the steel, it should be in the finer size. Bigger size inclusions leads to deformation of this inclusion, and it will become elongated, and it will give directional property. So if we have finer inclusions, that means distribution of inclusion is good, and it is very fine, smaller in size. So due to these superior mechanical properties and high corrosion resistance come into this metal. So we have a strip, or we have a metal of superior mechanical properties with high corrosion resistance. So you can see these are the very good advantages of the near net shape casting process. Okay, I'll stop here and I will continue the lecture from the next class. If you have any doubt, you can ask me here.